Good evening. My name is Karthigayan, son of SAMINATHAN. I'm from DEM 3A. My metric number is 14DEM19F1043.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Yo, Shimin. Okay, my name is Muhammad SHAFIQ HISHAM. Okay, I'm from class DEM 3A. Okay, my metric number 14 DEM 19F 1041. Okay, my lecturer name is Encik Shana bin Mustap. Okay, I want to discuss about the new project. Okay, the first is lab 2, uh, mass force and acceleration. Okay, and second lab 3, new project 2. Okay, equilibrium of force. Okay, let's go.
Okay, hi and assalamualaikum warahmatullahi wabarakatuh. My name is NURUL ATHIRAH binti ZAINUDIN. I am from DEM 3A. My matrix number is 14DEM 19F1045. So today I want to talk about engineering mechanic laboratory report for the lab 2.
Okay, today I want to talk about the theory. Okay, the Newton's second law of the motion question of the behavior of the object for which all exciting force are not balanced. The second law states that the acceleration of an object is dependent upon two variables, the net force acting upon the object and the mass of the object. The acceleration of an object depends directly upon the net force acting upon the object and inversely upon the mass of the object as the force acting upon an object is the increase and the acceleration of the object is increased. As the mass of an object is increased, the acceleration of the object is decreased. Okay, according to the Newton's second law, the acceleration is produced when a force acts on a mass. The greater the mass of the object being accelerated, the greater the amount of the force need to accelerate the object. The formula is F equal to ma. F means force, m means mass, and acceleration means and a means acceleration. Okay, speed is the rate of change in distance. In other words, it is how fast the distance changes in 1 unit of time. The mathematics displacement can be calculated from the following formula. The second formula is velocity v equals to distance over time, and unit distance short form d, and time symbol is t, and unit symbol is m over s. Okay, velocity is the rate of change in displacement. It is how fast the displacement changes in 1 unit of the time. The acceleration formula is velocity over time times by unit. Okay, thank you. Now I pass to my friend to talk about the apparatus and equipment.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad SHAFIQ HISHAM. Okay, today I want to explain about lab 2 engineering mechanic, force, mass and acceleration. Okay, my part is explain about uh, procedure and apparatus equipment. Okay, first lab 2. Okay, I want to explain about apparatus and equipment. Okay, first is scales. For to weight, the weight they have been set. Okay, second set of weight balance. Okay, for to set a given weight. Okay, third is stopwatch to set a predetermined time. Okay, and the last one meter ruler or protector set for make sure a predetermined distance. Okay, so next I want to explain about safety precaution. Okay, first, please do not do experiment without lecturer supervisor. Okay, or do not experiment without a professional or expert person. Okay, second, after finish experiment, okay, please arrange equipment. Okay, so so clean and soft and smooth. Okay, because equipment so expensive. Okay, the last be careful. Okay. Okay, so the next the procedure. Okay, number one, set up the apparatus and material. Okay, as shown in figure in a report. Okay, number two, record a value of M1 and distance of H. Okay, constant value. Okay, number three, release a system from O to N and record a time T. When M1 drop down, okay, repeat this procedure for different tests. Okay, number four, repeat this procedure with a different of M1. Okay, the different. Okay, and the last one is record the result at table below. Okay, repeat this experiment with different value. Okay, different weight. Okay, that's all. Assalamualaikum.
Assalamualaikum dan selamat sejahtera. My name is FARULFITRI bin GAFAR. In this video, I will discuss about result and analysis. Okay, result test 1. Height is equal to 20 cm. The mass given is 100 gram, 50 gram, 20 gram, 10 gram, and 5 gram. So we convert this mass to kilogram, which we get 0.1, 0.05 gram kilogram, 0.02 kilogram, 0.01 kilogram, and 0.005. Okay, now they are given from the result that we done the experiment. We get this time as a result, and then we to get the average time, we need to add all this time, add it, and we and divide it by 3, and we got this answer, which is average time. When we get average time, we can calculate the velocity and acceleration by using this formula. Velocity equal height per time, which when we divided it by time, the height, and we get 0.18 meter per second for 100 gram, and 0.17 meter per second for 50 gram, 0.16 meter per second for 20 gram, 0.17 meter per second for 10 gram, and 0.14 meter per second for 5 gram. And next, once we get all the velocity, we divide by time again, the average time, and we get acceleration, which when we divided 0.18 per average time, we get 0.16 for 1 and 0.17 per time, and we get 0.14 meter per second for 50 gram, and 0.16 per 1.29 equal 0.12 meter per second for 20 gram, 0.17 per 1.2 equal to 0.14 meter per second for 10 gram, and 0.14 per 1.547 equal to 0.10 meter per second for 5 gram. And then we put it in the table. That's for test 1. And then we go to test 2. The test 2, the height is 30 cm. The mass is same like test 1, just the height is different. And we get same like test 1, we change the mass from gram to kilogram by divided 1000. And then from the experiment that we done, we get this time, and we hit all the time that we get and divide by 3, and we got 1.05. And then for 50 gram we got 0.97, for 30 gram we got 0.83, and 10 gram we got 1.11, and for 5 gram we got 1.28. Okay. To find velocity and acceleration, we use this formula by using height per time, and we get for 100 gram we got 0.29 meter per second. For 50 gram we got 0.31 meter per second. For velocity 20 gram we got 0.336 meter per second. So 10 for 10 gram 0.27 meter per second, and 5 gram 0.23 meter per second. And then we get once we got the velocity, we can find the acceleration by using velocity per time. And as that, for acceleration 100 gram 0.28 meter per second. Next is 50 gram 0.32, 20 gram 0.43, 10 gram 0.24 meter per second, and 5 gram 0.8 meter per second. Okay, that's all from me. Thank you.
Okay, for the discussion, from the result, we can see the relationship between position, velocity, acceleration, and force. Based from the test 1, graph moves slowly with a height of 1.2 meters, and because of that, the velocity almost horizontal, so the timers are longer from the test 2. Then for the test 2, graph decrease faster and the velocity is lower, since the height is 1.3 meter and the timers are shorter compared than test 1. Okay, for the conclusion and recommendation, from this experiment, conclusion that I get is Newton's second law of motion was proved in this lab based on the data obtained. Based on the result from experiment, it can be determined that force is proportional to acceleration increasing when the mass increase. I can conclude the force is indeed a function of mass and acceleration, since two scenarios would supported the it. And the Newton's second law of motion is true from the result of the experiment. Overall, we obtained very good result, exemplifying the main principle of Newton's second law of motion. Thank you.